Okay, looks like I'm recording and hopefully my mic is on. Yes, okay. So I wanted to end the week just by talking about integration by substitution. I didn't give you any homework because I felt like you're going to get it in the class anyways. But I thought you probably need some help on it. But so I wanted to kind of talk about how to do integration by substitution. And I'll probably stick with, there's several methods to do it. I'll try and stick with the one that I think works the best. So, we're going to talk about integration by substitution. It's the last integral technique that you're going to learn. There's a lot more, but you're just not going to learn them. So if you can't integrate it the regular way, we go to integration by substitution. Those are only two choices, either straight integral or integral by substitution. You can kind of recognize an integral that needs to be done by substitution when you see something times its derivative. So like when you see an inside, so these parentheses are 2x squared minus 6, its derivative is 4x. So what I'm looking at is something times its derivative. And I know I couldn't do this by hand because I don't want to multiply that out 7 times. There's no way, right? So this has got to be substitution. So what do you do with substitution? Substitution is kind of it's just using the chain rule is really what it's doing. Here, let's do it this way. Okay, so what you want to do with substitution. I'm going to let u be the thing inside the parentheses. So I'm just going to define a new variable u, which is 2x squared minus 6. No, yeah, 2x squared minus 6, the thing in the parentheses. And then I'm going to take its derivative and call it du. So its derivative is 4x times dx, because it's not u, it's x, so it's times dx, all right? So the way that this is done typically, or one way, is to solve this for the second equation for dx. So dx is du over 4x. I just divide it by 4x. Now what I'm going to do is plug in the stuff that I have into this integral. So I have the integral of 4x. Now 2x squared minus 6, that's your u, so it's u to the 7th times dx. Well, dx is du over 4x. And what should happen at the end of this is the x's should all go away, which they do. And you have an integral that's solely in terms of u. So I have the integral of u to the 7th du, which I can integrate because that's 1/8 u to the 8th, right? So we get 1/8 u to the 8th plus c, but u is not u. We want to put it back into x. We know that u is 2x squared minus 6. So it's 1/8 times 2x squared minus 6 to the 8th power plus c. All right, so that's what u substitution refers to. I do this when I don't have a lot of other choice with things, okay? Things are more difficult integrals. The only options you're going to have right now are basic integration or integration by substitution. It's one or the other. All right, so we're going to move down a little bit. And actually, I'm going to annotate. I'm going to clear my screen. And we're going to do some other integrals by substitution. My suggestion to you is basically one kind of hard and fast rule. It works most of the time. Look for things inside a set of parentheses. That could be your u. Look for things inside a radical, inside a square root. That could be your u. In the exponent of an e function, so like e da 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 da, whatever this is, that's your u. Or the denominator of a fraction, so if you have 1 over da 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 da, then whatever this is going to be your u. Okay? So there's some suggestions for you as to what to do. Most of the time that'll work. So my plan with this was just to work a few examples so you can see again how this all works. So again, I got a square root here, so I'm going to let u be 6x cubed plus 3. So I'm going to take the derivative. So du would be 18x squared dx. So what I have right now is the integral of 18x squared times the square root of u times dx. Oh, dx is du over 18x squared. So du over 18x squared, and like magic, the x squareds and the 18s cancel. So what I really have is the integral of the square root of u is u to the 1/2 times du. So remember, to integrate that, you're going to raise it by a power. So 1/2 plus 1 is 1/2 plus 2/2 is 3/2, or do it on a calculator, I don't care. U to the 3/2. And what you're going to do is you're going to divide by 3/2, which means I'm multiplying by its reciprocal, so it's 2/3. Now all it's left to do is replace u. So 2/3, what's u? U is 6x cubed plus 3. And we're raising it to the 3/2 power. And don't forget the plus c for all these indefinite integrals, as usual. All right, so the second example, I've got an e, so I'm going to let u be, oh, this should be an x. This should be 4x squared minus x. So I'm going to let u be 4x squared minus x. So I'm going to let du equals 8x minus 1 times dx. So dx is du over 8x minus 1. So plugging everything in. Leave that part alone. I don't know what it is just yet. E to the, so the top of it would be u, e to the u times dx, which is du over 8x minus 1. Lo and behold, magically the x's cancel, they have to, equals the integral of 2e to the u du. Well, the integral of e to the u is e to the u, yay, so it's 2e to the u, which u is not u is 4x squared minus x. And we put a plus c on the end. Okay. All right, this next one, it does have a set of parentheses, so I'm going to let the u be the thing in parentheses. So we'll kind of draw a line there. So I'll let u be 8x squared minus 5. So du would be 16x dx. So if I solve for dx, dx is du over 16x. So let's plug stuff in. It's 2x over, that's u cubed. Dx is du over 16x. So the x's cancel. I have a 2 over 16, which is 1/8. So that's going to come out front. So it's 1/8 the integral of du over u cubed. Obviously, you can rewrite that. 1/8 the integral of u to the negative 3 du. So if I raise it 1, it's going to become u to the negative 2 divided by negative 2. So the 8 and the 2 multiply, so I get negative 1/16 u to the negative 2. If you'd like, you can put the u on the bottom. So we'll kind of go, I'm running out of room, so we'll go over here. So it's 1/16 over 1 over 16 u squared. No, that's not right. 1 over 8. Oof. 1 over 8. We'll just go like that. 1 over 8 u squared's on the bottom. Let's just rewrite that. 1 over 8 u squared, all right, but u is not u is 8x squared minus 5, so it's 1 over 8 times 8x squared minus 5 squared plus a constant, okay? Now with ln's, you probably, it just kind of depends, but you can't integrate ln, so we have to get rid of it. So this is a little different, but I know that the derivative of ln is 1 over x. So I have something times its derivative. This just doesn't follow any rules I gave you, but if u is the ln of 2x du, well, the derivative of ln is 1 over 2x, right? Times the derivative of the inside using the chain rule is 2 dx. So those 2's cancel, so it's 1 over x dx. All right, so dx, if I solve for it, would be x times du. All right, so we're going to plug stuff into the integral here. So this is the integral of u over x times dx, which is x times du. Looky there, the x's cancel. So all I'm doing is integrating u, which is 1/2 u squared. But u is ln of 2x, so it's 1/2 the ln of 2x, quantity of the whole thing squared, plus c. That 2 doesn't come out front because it's the ln squared and the whole ln and not just the argument. So that's the way it stays. All right, so this next one, I'm going to let u be the thing in the parentheses. So u would be 1 minus x. And if I take its derivative, du, the derivative of negative x is -1. So if I solve for dx, divide by -1, I get dx is negative du. So what I have here is the integral 1 minus x is u to the 50th times negative du. I'm going to pull the negative out front, just get it out of my hair. All right, so there it is. And now I'm going to integrate, so I'm going to raise it 1 power, so it's u to the 51st over 51. But u is not u is 1 minus x. So it's -1 minus x to the 51st power over 51 plus c. Okay. Now this last one, I don't have parentheses, I don't have radicals, but I do have a little fraction. So I'm going to let u be the bottom, the denominator. So u, I'm going to make u 5y minus 2. So du would be 5 dy, because that's the derivative of that thing, it's just 5. So dy is du over 5. So we're going to do this integral. I have 3, nothing I need to do with that. 5y minus 2 is u, and dy is du over 5. So I have a 3 and a 5. Those are constants. Those can come out front of the integral. So it's 3/5 the integral of 1 over u du. And hopefully by now you know that's the ln of u. Some people would say the ln of the absolute value of u, but we're not going to worry about that here today. So it's the ln of u, but u is not u. 3/5, it's the ln of u is 5y minus 2 plus c. Okay, so hopefully that helped a little bit with integration by substitution. Just meant to give you some help for those that watch this. All right, I will talk to you next week. Will be I think our last week of class, mostly working on final prep for 1325. All right, have a good week. Talk to you later. Bye.